Okay, so today we are going to be looking at rational exponents. So the first thing I want you to do is look at these four up here and see if you can find the pattern. So looking here in this box, I want you to take a few minutes, pause if you need to, but see if you can find the pattern between like the square root of 3 and 3 to the 1/2 power. The fourth root of x to the fifth and x to the 5/4 power. So do you see a pattern? Hopefully you see the pattern, the following pattern. So we have the base and the exponent in the radical, and then we have the index on the outside, and then when I rewrite that, it's base to the exponent over index. So that fraction is the exponent over the index, which is exactly what we've been doing with the nth roots lesson. For example, when we had the fourth root of x to the 8th, you would tell me that that is x squared. So what you were really doing that you didn't know, but you were really taking 8 divided by 4. Okay? Or if I said, what's the third root of y to the 9th, you would do 9 divided by 3 and tell me the answer was y cubed. So you've been doing this, you just didn't really know that there was a pattern. So now you can see the pattern. We have exponent over index when we write these in rational form. So we have a radical form, which includes the radical sign. That's how you know that's radical form, it has the radical sign. And we have a rational form, which includes a fraction. Okay? So, looking on, let's look at some example problems. And for these problems, all you need to do is write the answer in the opposite form that it's in. So this is in rational form, and we want to write it in radical form, which means our answers should all have a radical sign. So let's do 2 together, and then pause and do 2 on your own. So this first one, actually this first 2, so we have the 6th root of 3, because this was the exponent, and this is the index. Okay, so here we have exponent, index. Okay, try the next 2 on your own. Okay, so now let's check our answers. So you should have the third root of 12 squared, and next you should have the square root of x. Now, these are not asking for any simplification, just changing form, so make sure you read directions. Because if I had asked you to simplify these, then right here you would do you would get the cube root of 144 and break it down and so on. So that's how those work. Okay, so for the next one, we are going to write in rational form. So they have a radical, and so we're going to be writing a fraction. So we have, now this first one, remember, if I don't have an exponent, what is it assumed to be? It's assumed to be a 1. If I don't have an index, what is it assumed to be? It's assumed to be a 2. Now, you'll never write those 1 and 2s. However, when you write this as a rational exponent, you will write the 1/2. So this is the square root of 51 is the same thing as 51 to the 1/2 power. So the cube root of 37 is the same thing as 37 to the 1/3 power. So that's kind of a way to write it in your calculator. And there's several ways, but if you wanted to actually know the cube root of 37, in your calculator you could do cube root caret 1 over 3. As long as you put that in parentheses, that would be the answer. So then you could find the decimal approximation if you needed it. Okay, so for the next one we have 15 to the 3/4 power, and the last one is a bit tricky because all of that has an index of 3. So you can write 6 to the 1/3, x to the 1/3, and y to the 2/3, or you can do 6xy squared and put parentheses around the whole thing to the 1/3. Okay, so either one of those would work. Now, why do we have rational exponents? Why do we even need to care about these fractions? And it's for problems like these. So these are some pretty tough. This starts to get a little bit tough because we're no longer just using the laws of exponents. We're applying them in kind of a further step, a little bit harder kind of problem. So down here, I have, these are some questions that you kind of ask yourself as you're going, because it's hard to know when you have simplified these examples and when they're finished. So these are some helpful hints and some questions to ask yourself. So looking at this first problem, we have the cube root of x to the fifth and the cube root of x to the fourth. So the first thing I'm going to do in most of these problems is change them to a fraction exponent, change them to a rational exponent. So this is x to the 5/3 times x to the 4/3. Now it's just one of our basic laws of exponents, because we know that if we have like bases and we're multiplying, what do we do to the exponents? We add them. So if I have 5/3 and 4/3, that equals what? 9/3. Well, 9/3 is x to the third. So now I'm done. Okay? So I had two radicals, I changed them to rational form, and then I added the exponents. Okay? So next we have a division problem. So I'm going to subtract the exponents. So first change them to a fraction. So a to the 3/2 and a to the 5/4. So the fractions that I'm going to be subtracting are 3/2 and 5/4. Now there's a couple different ways to do this. You could find a common denominator, or you could use a calculator. I used my calculator quickly, and I realized that 3/2 minus 5/4 is 1/4. So my answer is a to the 1/4, or the fourth root of a. Now, one of these down here says that your answer should always be in the format the question was given, when possible. So because my question had a radical, then my answer should have a radical, when possible. Okay? The next one is a power to a power. So what do we need to do with the exponents? We are going to multiply the exponents. So I have x to the 1/2 to the 4th. So that is x to the 4/2, or x squared. Okay, so you do have to remember your rules of fractions when dealing with these. So once again, I changed this to x to the 1/2, then I had 1/2 times 4, which is 4/2, and that is x squared. Okay, for the last one, we have a negative exponent. So what do we do with the negative exponent? We move it to the denominator. So now I have x to the 1/3 times x to the 1/3. So I took this and I moved it to the denominator. Now I have two terms that I'm multiplying together. So what do I do to the exponents? Add the exponents. So now I have x to the 2/3. Now one of our rules is that there cannot be rational exponents in the denominator. Okay? Can't be rational exponents in the denominator. So I need the denominator to be 1. This is the trickiest, hardest question. The way I can make the denominator 1 is I can multiply by x to the 1/3, because 2/3 plus 1/3 is 3/3, which is 1. So this fraction right here is always going to be whatever would make it 1. Okay? So I want to be trying to make 1. So when I do that, I'm going to multiply the top and the bottom by x to the 1/3. So my final answer is x to the 1/3 over x. And that seems really weird, and that seems odd, but that's just the way it goes. So we're going to do several more of those. I want you to try some on your own. The key is that you want you want this fraction and this fraction to equal 1. So if I have 4/5 and I want it to equal 1, then I would add 1/5. If I had 3/7 and I wanted it to equal 1, I would add 4/7. Okay? So there are practice problems. I'm going to go ahead and assign you those practice problems in class on Monday. So on Monday we will do all the practice problems. So hopefully you'll have your video ready and you'll be ready for class on Monday.